Hello everyone, I am Sejal of BCom first year, and today I will be giving presentation on the topic regression from business statistics. So let's get started. Regression. Regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable and a series of other variables. Here, the definition says that regression determines the relationship between series of dependent and independent variables. Here, the dependent variable is denoted by y and the other variables, that is independent variables, are denoted by x. So, there are two types of regression. That is, the first one is Karl-Pearson regression method and the second one is least square regression method. Karl-Pearson regression method. Now, in Karl-Pearson regression method, we have to formulate some equations. The first equation is y on x equation, and the second one is x on y equation. Under y on x equation, we form an equation which goes like y minus y bar is equals to byx multiplied by x minus x bar. Here, the y bar and x bar are the means, the mean of the series, mean of the y series and the mean of x series. And this byx is equals to the number of the series, the numbers in the series, the observations, multiplied by summation of xy minus summation of x series multiplied by summation of y series, whole divided by n multiplied by summation of x square, and x square is the x series, the dx series, minus summation of x whole square. This is the y on x equation and it is byx. Now let's move to x on y equation. It goes like x minus x bar is equals to bxy multiplied by y minus y bar. Here the byx is equals to n multiplied by summation of xy minus summation of x into summation of y, whole divided by n multiplied by summation of y square minus summation of y series whole square. Now the difference between these both equations and the byx and bxy is, here in the denominator it is summation of x square and summation of x whole square, and in this formula we have the summation of y square and the summation of y whole square. Now we have three more formulas of bxy, that is bxy is equals to r multiplied by the standard deviation of x upon the standard deviation of y. Another formula is covariance of x and y upon standard deviation of y to the whole square, and byx is equals to just the opposite of bxy, that is covariance of x and y upon the standard deviation of x and its whole square. We have another formula that is for standard error of estimation, and that goes like under root 1 by n multiplied by the summation of y minus ye whole square. Now let's get into the question. So the question goes like, calculate two regression equation with the help of data, also from regression equation. Also form regression equation. Calculate expected sales when the profit is rupees 67,500. Calculate expected profit when the sales is 73,500. and we have given the two series, that is of sales and profits, and the both series are in thousands. So let's assume the sales series is X and the profit series is Y. So let's look at the question. Now its solution is, we have the sales series written on this side and the profit series, that is Y, written on this side, and now we have to calculate the dx and the dy series. And how will be calculating that? We will calculate by subtracting the mean of this x series from the numbers of this x series. For that we'll be needing mean. So how will we get mean? The mean of x series would be the summation of that whole x series divided by n. So here we'll be adding up this all numbers, that is 546, and after that we will divide it by the 8. 8 is the number, the total number of this series, that is 8. So we have here 546 divided by 8 and we got our mean as 68.25. Similarly, the mean of y series we got as, the summation of this y series is given, or we have calculated as 548 and divided it by 8 and we got 68.50. So by this we calculated the mean of x and y series respectively. Now we have to calculate the series dx and the series dy, and we will calculate it by subtracting the mean of x series by each and every number of this x series, and by doing that we have calculated the dx and the dy series respectively. So this is our dx series and this is our dy series. Now after calculating dx and dy, we have to multiply the dx and dy series, and here we have multiplied the dx and dy, and by doing so we got the series and we have calculated the summation of dx and dy as we need in the formula. Moving on, we have calculated dx square and dy square, and we calculated it by just squaring these numbers, and we have calculated dy by squaring these numbers. By doing so we got the dx square and the dy square, and also we calculated the summation of these both series. Now all we have to do is just reading the question once again, and we have been asked two regression equation. So the two regression equation are the x on y and y on x. So x on y is x minus x bar, as we have seen in the formula, this x on y's equation. It goes like x minus x bar. So x will be write x as it is, and in place of x bar we'll write the mean of the x series, and here in place of y bar we'll write the mean of y series. And the extra thing which we have to calculate is this bxy. So we'll calculate the bxy. Here I have calculated the bxy. Now the formula of bxy is n. Now here our n is 8. So we have a n is equals to 8. Now we need the summation of xy. Now this xy is nothing but the summation of dx and dy. So we'll write, or we can say that xy is also known as the dx and dy, not this and this y, just this dx and dy. Okay, so we'll take the summation of dx and dy, and that is 21. So we wrote it as 8 into 21 minus summation of x series and summation of y series. So again, the summation of x and the summation of y is not the actual sales and profit, it is the dx and dy. So that is 0 and 0. So we have written here 0 and 0. Now divided by n multiplied by summation of y square. Now this y square is dy square. This is dy square. Okay, so we'll multiply 8 into the dy square. We have n is equals to 8 multiplied by, let's have a look what is a dy square. This is 40. So we have written 40 over here minus the summation of y, that is dy is 0, as we have written above this, and we have to take it whole square. So the 0 square is 0. So it doesn't change. Now after solving this thing, we got 0.525 as our dxy. Now we'll be putting this in our equation, that is x on y. Similarly, we'll be calculating y on x and we get this as y on x. Okay, now we have calculated the x on y and y on x, both the equations. Now in the equation we are also asked to calculate the sales when the profit is 67,500 and calculate the profit when the sales is 73,500. So all we have to do is just put these values in the equation which we have calculated. Okay, so here we have this thing in thousands, but here we have just cut off their numbers, their thousands numbers. So here we will divide 67,500 by 100 by 1000. So we will get 67.5, and here we have to calculate sales. So the sales is x series, so we'll put in x and y equation. Here on putting 67.5 in x and y series, we got the sales is equals to 67,725.5. So that is our sales when the profit is 67,500. Now we have asked to calculate the profit when sales is 73,500, and we have done the same thing over here. We had chosen the equation like y on x, and we've put the value, that is 73.5, into that equation, and we've also multiplied these both equations by 1000 because we have already reduced this value to make our calculations easier, but we want answers in thousands, so we have multiplied thousands both the sides. Okay, so by doing so we got the y, that is we got profit when the sales are given, that is when x is given, the sales is given, and we have asked to calculate the profit, so we have calculated that thing. So these are the things which we have asked in the question. Now at last we have to write the interpretation of this thing. So the interpretation goes like, when profit is 67,500, the company should reach the sales of 67,725.5, and when sales is 73,500, the company should reach the profit of 70,726. So this was our equation of the regression equation. Thank you.